I'm Hannah McDaniel, and I'm going to talk about microplastics in the ocean. Imagine you're a fish swimming around in the ocean. You're pretty happy, right? I bet you are until you realize your home is being littered with microplastics. From the local rivers to the vast oceans, microplastics are polluting our water and harming our wildlife. These plastics are becoming a very big problem in the marine ecosystem, and it all starts with a plastic bottle thrown into rivers upstream in places such as Nebraska, South Dakota, and Montana. I'm going to talk about what microplastics are, their environmental impact, and solutions to reduce the amount of microplastics in the ocean. First, what even is a microplastic? A microplastic is a piece of plastic that is smaller than 5 millimeters in length. They are near invisible, making them harmful to animals in the environment. As most other things, there are many different types of microplastics, including microbeads, fibers, nurdles, and fragments. According to the University of Southampton, microbeads are a small and highly unnecessary plastic bead used in exfoliating and personal care products to remove dead skin. Fibers are synthetic fibers used in making clothing. The University of Southampton also says that as many as 700,000 fibers can come off a single piece of clothing after every wash. Nurdles are basically plastic pellets that are going to be formed into a product. And fragments are simply the name, a small piece of plastic that is broken off a larger piece. How do these plastics get to the ocean, you ask? According to the National Oceanic and Atmospheric Administration, also known as NOAA, plastics are tossed into waterways in the ocean and are broken up into small bits, which are then considered microplastics. Other microplastics enter the ocean through waterways. The bottle that gets thrown into the river in Nebraska eventually breaks apart into pieces and gets carried all the way to the ocean. Next, the environmental impact that microplastics have is huge. .co.com says that toxic pollutants like pesticides float on the surface of the water. This property makes them attracted to microplastics that are floating. When an animal eats that piece of plastic, mistakenly for food, not only did it just eat plastic, it also ingested the toxic pollutants that was on it. Microplastics also can serve as a kind of raft for small organisms. This may cause them to travel too far and become a vector for spreading invasive species where they aren't wanted. One example of microplastic problem is in the Mariana Trench south of Japan. Recent research by the National Geographic states that in a 1 liter sample of water from the trench, it can contain as many as 1,000 pieces of plastic. They also use the analogy of food in a sink. They say that like how food particles come together in the middle of a sink after washing dishes, microplastics are coming together in the ocean. Geochemical perspective scientists published research that says the amount of microplastics found in the depths of the ocean could possibly account for almost all of the missing plastics from around the world. Finally, there are many ways that mankind can combat this problem. One way is to simply recycle plastics and keep them in waterways. Yes, even plastic that ends up in the rivers of Nebraska can eventually make it out to the ocean. We can also reduce the use of plastics in our everyday lives. We humans use way too much plastic. This can be as simple as bringing your own reusable shopping bags to the store or not using a straw when getting a beverage at a restaurant. Some countries like Europe are facing a problem head-on by making laws. According to the European Parliament's website, the EU put a ban on intentionally adding unnecessary microplastics to products such as cosmetics and beauty products. The US has also put in laws similar to the EU's to reduce the use of microplastics. Haikai magazine has a story about a group of Slovenian scientists who found that jellyfish mucus can be used to filter out nanoparticles of gold in polluted water. They then hypothesized that the mucus can be used to filter out microplastics in the same way. Unfortunately, when they experimented their hypothesis, the mucus failed to effectively remove the plastics from the water. But the scientists think that this is due to the quality of mucus. They are hopeful that they will find some better quality mucus that can get the job done. To wrap things up, imagine that you were that fish again. How happy would you be if you knew your home wasn't going to be littered with plastics and pollution? I know I would be pretty happy. That change starts with us, Nebraskans that choose to recycle plastics instead of tossing them into the ocean. This In this speech, we learned that what microplastics are, their environmental impact, and solutions to reduce the amount of microplastics that end up in the ocean. Thank you for watching my speech.